Unit 5, Section 3. Today we're going to be taking a look at solving systems of linear equations using this new strategy called elimination. And it's called elimination because we are going to eliminate one of the two variables in our equations and find the value of the other variable. So our key concept here is just that. It's our strategy. We're going to add or subtract equations to eliminate one of our variables, solve the resulting equation, which will be in one variable, then take that value and plug it back in to solve for the other variable. Then we always write our answer as an ordered pair. So our solution to systems of equations is always an ordered pair. All right, let's jump into an example, and I think you'll see what we mean here by solving using this method of elimination. I have the system of equations 3x plus 2y equals 7 and negative 3x plus 4y equals 5. So if I combine these two equations through addition, I will eliminate one of my variables. And here's what we do when we do that. We're going to combine like terms. We're going to add these two together. So we're just going to add down our columns because they're all lined up as like terms. So 3x plus a negative 3x is 0x. 2y plus a positive 4y is plus 6y. And then 7 plus 5 is 12. And I'm just going to copy down that equal sign. So I've created this equation now, which is 6y equals 12. The 0 times x is just eliminated. There you go. We eliminated one of our variables. Now I can solve for the value of y by dividing over my 6, and that gives me a y value of 2. All right, we found our value for y. Now we need to find out what x is, and it doesn't matter which of these two equations, the original ones that I pick, I'm going to rewrite one of them with my value of y substituted in there. So let's just take the top one. We have 3x plus 2 times the y value, which we said was 2, is equal to 7. All right, that gives me 3x plus 4 equals 7. Subtract the 4 over, and we have 3x is equal to 3. Divide over the 3, and we get an x value of 1. All right, we found our x, we found our y. Our ordered pair is 1, 2. In this ordered pair, 1, 2 is the solution to my system. If I were to graph these two linear equations, they would intersect at the ordered pair 1, 2. All right, let's try another example. It's a little bit more difficult here. I got a system, the two equations, 10x minus 9y equals 46 and negative 2x plus 3y equals 10. Now if I just combine these two, I won't get rid of one of my variables. So what I need to do is create an equivalent equation, and I'm going to create an equivalent equation with this bottom equation here. And the way I'm going to do that is I'm going to multiply the entire thing by 3. In other words, I need to distribute a 3 to each one of those terms in that equation. All right, so I think you'll see why I'm doing that here in just a second. I'm going to copy down the first one. I got 10x minus 9y equals 46. And my equivalent equation for that bottom one will be 3 times negative 2, that's negative 6x. 3 times a positive 3y is plus 9y. And then 3 times a 10 is 30. All right, now hopefully you can see what we just did right there. I'm going to highlight it. We created these additive inverses. So now when I add these two equations together, the y's will cancel each other out. All right, and that's what we're going to do. We're going to combine these two equations by addition. We're just going to add down the columns. 10x plus a negative 6x is 4x. Negative 9y plus a positive 9y is 0y. And we're not even going to write it. It's just eliminated. And then 46 plus 30 is 76. All right, we are now going to divide over the 4 here, and we'll end up with x is equal to, all right, 76 divided by 4 is going to go in there 19 times. All right, so x is equal to 19. So once we find our value of x, now we're going to take that value and substitute it back into one of our two original equations. It doesn't matter which one we choose. We'll take that first one, negative 2 times 19 plus 3y is equal to 10. So that's negative 38 plus 3y equals 10. Add over the 38. That gives me 3y is equal to 48 divided by 3, and we get a y value of 16. All right, so here is our ordered pair. Our ordered pair 19, 16 is the solution to this system. If we were to graph those two linear equations, they would intersect at that point. All right, so just to recap that strategy, if we don't have a number in front of a variable that will add to 0, then create an equivalent equation like we did so that they do add to 0. All right, let's try another example here. Example 3, solve the system by elimination. All right, if I take a look here, I can see that I don't have that coefficient again. So we're going to multiply both of these. Now we're going to create an equivalent equation by multiplying the top one through by 2 and the bottom one through by -3. And again, hopefully you'll see what we're doing here. All right, that gives us 18x plus 4y equals 78. On the bottom side, we got -3 goes to each of those, and then we're going to end up with -18x minus 30, excuse me, minus 39y is equal to 27. All right, now we can combine those like terms, or sorry, combine those two equations by adding straight down the columns. We're going to have our x's that are eliminated. 4 plus a -39 is -35y. All right, we set that equal to 105 when we add 78 and 27. Next, we'll divide off a -35, and we get a y value of -3. All right, we'll take that -3 for y and substitute it back into one of our two equations here at the beginning. We got 9x plus 2 times -3 is equal to 39. That gives us 9x minus 6 equals 39. Subtract, add that 6 back over to the right hand side. We get 9x is equal to 45, and when we divide off that 9, we'll have an x value of 5. All right, so our ordered pair here is 5, -3, and that is the solution to this system. All right, for our final example for today, we're going to solve this one last system of by elimination, and it throws yet another curveball at us here. So you see we got 3x plus 2y equals 4, and then we have 2y equals 8 minus 5x. So we're going to rewrite this bottom equation by swinging this 5x back over here, and then we're going to have some equations that look a little bit better for us. All right, so if we add that 5x over to the left side, we'll have 5x plus 2y equals 8. All right, now you can see that we have a positive 2y and a positive 2y. So instead of adding these two equations together, we're actually going to subtract them from each other. So watch how this goes. We have 3x minus 5x is -2x. Then we have 2y minus a 2y, and that eliminates the y's. And then 4 minus 8, which is -4. Next up, we're going to divide both sides by -2. That gives us an x value of +2. All right, finally, we're going to substitute that back into that second equation to find out what our y value is. We're going to put in 2 for our x, and that gives us 8 minus 10, so 2y equals -2. Divide over the 2, and we get y equals -1. So our ordered pair here, our solution to this system is 2, -1. All right, that's it for today. We'll tackle example 5 in class tomorrow.